So I just want to pause and I just want to ask a question to the whole class. Like, what are y'all trying to do right now to be able to sketch this function out?
We can find the zeros for the second equation.
Okay, so we're trying to find our zeros. So the zeros kind of being really important. So is it just the zeros though that we need?
No.
What else do we need? We need what? The lines, those factors. Okay, so huh? So that's what I was going to talk about for a second. Did it pass? Okay. So we don't just want the zeros, we want the entire line. So just want to emphasize this, we're going to come back to this in a second. When I look at 2x minus 2, right? Well, first off, what did y'all start to do here to get started with graphing this function?
Set 2x minus 2 to 0.
Just the 2x minus 2?
Yes.
Say it again, Jay. So remember, I can't just magically set 2x minus 2 equal to 0, but if I want a 0, what is my output? 0. Okay. So that does allow us to set 2x minus 2 equal to 0 using what property there, Macarian? Macarian? What property allows me to then set this 2x minus 2 equal to 0? Okay, so zero product property. Sweet. So we solve it out. X ends up 2x equals 2. X ends up equaling 1. Because I do want to know, like I see a 2 marked right here. And 2x equals 2. But if 2x is equal to 2, what does x equal to?
Wait,
1. If 2x is equal to 2, what does x equal? 1, right? There we go. So make sure we finish that. So it's not 2 here, but a 1. But I still need, I'm trying to get us up to the second piece. That's why I'm moving a little bit with this. But the x equals 1, what else do I need in order to graph this part of the function?
Y-intercept.
Okay, what is my y-intercept?
-2.
Do I have enough now to graph my line?
Pretty sure. Yes.
Pretty sure. I will point this out. Does anyone know what the slope of this line is? Hopefully.
Up 2 down. I mean up 2 times.
So notice it's up 2 to the right 1, just like up 1, 2 to the right 1. So if you want more points, you just keep using your slope. So remember, use your slope, use your y-intercept, use your x-intercept, graph that line, okay? But what I want to emphasize before I have you go back to working in your small groups is we also need this parabola here. So what methods do we have available to us to, when we have a standard form, right? That's a standard form of quadratic, set equal to 0, quadratic formula. Remember, there are other strategies, but the one I recommend the most, because of time constraints, quadratic formula. Do not use inverses here, right? When can we use inverses with properties of equality?
What case?
So remember, when we have factored form, just like here, we use the zero products property. When we have vertex form, we want to use those inverses, but with a quadratic formula, or standard form quadratic formula. Remember, I've told you in the past, it doesn't matter when you learn it, it matters that we learn it. And so this is where I'm building in those previous units to help you develop proficiency with these skills. So I guess Maddie's already crushing it and doesn't feel like she needs to pay attention to this. So if you need help with the quadratic formula, you're going to go to Maddie, right? Okay, just make sure. So make sure that you are learning this together, right? I'm here, Mr. Hobby's here, but there's also 22 of us in this classroom today. Use each other's resources when we're not there. So let's go find... Why? Let's use each other as a resource to find what my zeros are for this quadratic, and we'll come back together in a few minutes. Once you do that, by the way, don't stop. I want to know what g of x looks like. So help each other with that quadratic formula. What are we trying to graph? I need y'all to go back to the directions on the Frere model if you have it out. What do the directions say there? I think it says same as mild, but what does the mild say? Determine the multiplicity of each zero, then determine, don't ignore the standard form part, just sketch the polynomial, right? So guys, so we're trying to sketch g of x.
Yes.
Hey, Tyler, you with me? Right here? Okay. We're trying to sketch g of x, but in order to sketch g of x, what do I have to have first?
Oh, that's.
I need the zeros, but I need more than just the
The
zeros.
lines.
Do I only have lines this time?
No, you got the graph.
The
Right.
parabola.
So notice, guys, remember, we have a linear function. We already graphed that. We're trying to find the zeros of this so we can graph this. And so I'm going to come and check on a couple of groups. I want to say this so that you can hear this and I know to come check on you first. The zeros we should have gotten were 1 and 3. If you did not get 1 and 3, let me or Mr. Hobby know so we can come by and check on you. But from here, so we have, what zeros did I say? 1 and 3. So we have 1, we have 3. What else do we know about this function to help? The y-intercept is what? Okay, we do have a double root, but remember that double root's for g of x, so hold on to that for g of x. I'm talking about this function right here. There's something else critical that we're missing that we need to be able to sketch that out. We have the y-intercept. Taj, you have something over there that we haven't talked about yet. Notice Taj has a parabola there. So remember, that's g of x. That's the final function. I'm talking about the parabola. Like, look, what does Taj have in his parabola? If y'all can scoot to the side. What does Taj have in his parabola that I don't have here?
Oh, he vertex.
The vertical line.
The lines.
Yeah, but I'm just talking about the parabola, guys. So remember those vertical lines? Okay, line of symmetry can be helpful, but let me rethink how I'm going to phrase this. Guys, what's my concavity? Let's just make it a plain thing plain. It's concave up, right?
Yes.
Guys, I don't have to do much else. Once I have my zeros, if I know that that parabola is concave up, can I sketch what that parabola looks like?
Yeah.
How do we know that the parabola is concave up here?
Because it's positive.
Be more clear than just
It's
the
positive.
Ooh, not because the y-intercept.
A.
The a. Remember how it's ax squared plus bx plus c. You already identified the a, but remember, whatever this a is understood one, that a is positive, so our parabola is concave up. Notice this is all from Unit 2, right? So we're reusing all this stuff from Unit 2. It gives you chances to master this. Let me know, let your team know, let Mr. Hobby know if you have questions about it. But I now need us to try to figure out what g of x looks like. Once again, if you did not get the zeros of 1 and 3, you need to let us know so we can help you figure out where it went wrong. All right, let's get back to it. Let's figure out what g of x looks like. Some of us are actually completely done, but most of us are not. So I need some of us to pay attention at this point and look at this. Look, I've got how many functions graphed here right now? I got 2 graphed. 2x minus 2 times x squared minus 4x plus 3. Those are my 2 factors. In purple is my line, y equals 2x minus 2. We've got to be able to recognize mx plus b. That's a linear function. When I look right here, what tells me what type of function this is? The square. That square alone tells me that it's going to be a quadratic, which has what shape? Parabola, right? So we got all those factors, we got our factors graph, we got our zeros, all those fun things. And some of us finished from here, but quite a few of us have not. I see some indications about positives and negatives around the room. Remember, once we got our factors done, what did a lot of us draw to help us visualize things? The lines in between the points, so the lines at the what? At the x-intercepts. Remember, I want to mark those x-intercepts. Boom. And boom. Because what are we essentially doing with those 2 functions? This is a core foundational piece that we need to hold on to. What are we doing with those 2 functions? What about them are we multiplying? Not just the roots. Say that again. We're dilating the functions, but we're multiplying their outputs, which is why we care about those zeros so much. Cannot forget this, multiplying outputs. So for instance, for both of these factors, what's the output for both of these factors at this 0?
1.
The output is 0. That's why we call it a 0. 0 times 0 is?
0.
That's why g of x has a point there.
Huh? Say, huh, what? What's that?
But right now it's learning math. I know if we got issues, we probably need to take care of it, but right now we need to learn some math. What kind of, not even what is it, but what kind of outputs does this line have right here?
Positive.
We have positive up here.
Yes.
But what is this output?
That's neutral.
Oh.
Wait, it's not under O.
Is it not positive?
It's not under O. It's not under O over.
Right, so what's the number?
Zero.
There we go.
Oh, okay.
Oh, that's what you.
Yeah.
I mean zero neutral though. Basically, is it not?
If you think, like, if you're talking about, I don't know, chemistry or something like that, then yes, but like in mathematics, positives, negatives, and zeros, right? Zeros in between. And so we take a positive, we multiply it by 0, what do we get?
Oh, zero.
0. Okay. So, now Taj, earlier you made the note of, you said positive here times negative, and you were like, but I know there's supposed to be 3
Yeah.
positives, negatives. Why were you thinking there's supposed to be 3?
That was root, and I was like, it gotta be like something with that in the end, but like, in the end, it was something all you can also.
So there's that, and so maybe that was it. But one thing I heard you talk about, and I want you to think about, was you talked about 3 zeros, right?
Yeah.
And so what I was hearing was maybe you're thinking because there's 3 zeros, you need 3 positives or negatives.
Yeah,
But it's not about the number of zeros. It's about the number of what?
factors.
Factors. How many factors do we have? So we have 2 factors. And so we just need to think about that. A positive times a negative is? So to the left of this x-intercept, what is everything? Negative. In between here, what type of values does this linear factor have? Why are they positive? It's above the x-axis. Be careful, it's not just because it's going up, it's because it's above the x-axis. The quadratic, the parabola has, and a positive times a negative is? A negative. So it was negative and then it goes back to being negative. How does that happen? Say again. Why is it bouncing though? There's no root. Do not forget, right? A lot of us, I know Cameron immediately saw that earlier where he said, hey, that's going to be a double root. Isn't that what you said?
I did too.
How did we know it's going to be a double root from the beginning? Because x equals 1 how many times?
2 times.
Twice, right? X literally equals 1 twice. It's x equals 1 with a multiplicity of
25.
I mean
2. Multiplicity of 2. And so it bounces there, then it goes back into the negatives, and what happens at this 0? It goes into the positives. So, what type of function does that look like? What shape should that remind us of?
quadratic.
The white here looks to me like a cubic.
I like it.
That looks a whole lot like the cubic shape that we've seen this whole time, right?
No.
Yes, it is.
No.
So that looks like every cubic just about that we've seen this whole time, despite what the one
What are
saying.
you talking about? What
This
part?
white curve in here,
I didn't see that.
oh,
Gee, it's
So maybe we should
covered
have some
by-
questions.
It's covered by like 5 lines.
well, I color coordinated so that purple line is my linear factor, the blue is my quadratic factor, and then the white is my cubic. Now, not just the shape, and this is what I need to pay attention to because we're going to use this as well. The shape is the shape of what type of function? That white is the shape of what type of function? A cubic. If I see that shape, I know that's a cubic function. What else tells me that that white function is going to be cubic?
3 0.
There we go. Yeah. I didn't realize I taught dolphins. I thought I taught human beings. Anyways, so right here, remember this linear factor will have how many zeros? 1 0. This quadratic will have 2. And so that's a total of how many? 3 zeros, right? 3 zeros is a third degree, is a cubic. It's all about the zeros. I need to collect the twitch so it doesn't distract us in class.
I ain't gonna lie, Miss Kenny.
Yeah, we do that too, it's fun. Alright,
Every day. Oh, God, every day.
I'm gonna give you a couple of minutes to make notes on your Frere model, whatever you need to about this problem. Improve your learning, improve your understanding. Specifically, can I see this? Remember, this is page 6 of the Unit 4 Frere models. Okay? From that medium section.
Oh, but I thought it was a bird.
Where's that from?
So, if you don't have that with you,
Where did
I don't believe it.
I'm not asking, I'm just asking you to do some learning right now.
I was over there.
Addison, Preston, y'all don't need to take any notes? Let's go.
She's a W note.
Take notes.
Bobby did.
Be assigning a math assignment so you can get. Listen, hold up.
If you're nice to her, she's gonna be nice to you.
Hey, listen up. The mathy assignments, I know sometimes they do take longer, but one of the things is going to be finishing the one that many of us have not finished. And they are designed to help you improve your understanding. If there are things we're struggling with and it's taking us that long, then that means that that's something we really have to work on and make sense out of. Now, say again. So there are different units, and so I want to make sure that so you look at it. Okay. Excuse me. Hey, excuse me. We need to be more focused when we come back from lunch. And so we need to go ahead and have, where is it? This page on 157, 158 is Mr. Hobby has gone past his desk angrily. Mr. Hobby has passed out a sheet of paper to everybody. It's on the desk somewhere, right there. It says domain, range, and extrema of functions. Yeah, there's one for each person.
Oh, man.
That's the last page for this Frere model for this unit. I didn't get a chance to make solutions yet. I made this extra, realizing that most of us needed it.
We'll make them.
Do what?
Said make them.
Make one what?
Wait, what you said make them. What you said you didn't make them. So I said make them.
Make what?
What you just said you didn't make. Mr. Kenny.
What did I say I didn't make?
Hey, did you wear a large?
Yeah.
You definitely did make them.
Once I get started on this, when I get us to go into vertical search.
I'm sure I did.
Except for you and Jenny.
Alright, eyes and ears here. Not talking. We are three. Come on. What did I just say?
What?
You didn't even hear what I said. Leave. I said eyes and ears here, no talking, and then immediately you said something.
Okay, McQueen.
Come on. You messed up.
Okay.
So, from here, move forward. No, get your hand out my door tonight. Alright, we're about to end up going to the bathroom after lunch because this is ridiculous. I can't have 5, 6 people showing up 4 minutes after the bell rang.
4. I thought the bell rang at 1 o'clock.
Yep. Sorry, it's 1:03 and 50 seconds. You're right. So,
Don't say y'all.
but you did show up late, didn't you?
101.
Girl, you just walked in. It was already 1:03 when you walked in.
Mr. King's in the bathroom right there. It didn't take me no 3 minutes.
Jamie, I watched when y'all came in. It was after 1:03 when y'all walked in. Yes, Cameron.
Come back after close.
Okay.
That person probably did.
Huh? One second. So, we'll close it for now. I'll look at it in a second. We got to get here on time. Your education matters. You already have 5 minutes less in this class than you do in first, second, and fourth. We need that 5 minutes. Like, we want to get upsetty when we don't understand stuff, but we don't want to be here on time. So, it's time to learn, get here at 1 o'clock. If you want to be a minute late because you're using the restroom, that's fine. If the bathroom is locked, come and let me know first, before you just go elsewhere. It's 10 seconds from that bathroom to here, right? Just give me a heads up. Sound good, Cameron? Alright. Hood off, please. Kamaya, hood off, please.
Ms. Kenny, technically, what did that make you more late?
Oh, it's part of this.
Oh, yeah.
So,
If you came all the way back,
yesterday, we talked about domain and range. That's why I created a Frere model for y'all on it. Give me a recap. What did we talk about with domain?
It's the X of
left,
value
right,
and out.
left, right, X
So,
X
value.
Set of all X values, also called inputs. Which is why, Dewan, we looked which direction.
Left, right.
Now be
Oh,
careful, and something I want to remind you of is, you look left or right with what mathematical representation?
the book. Miss Kenny.
Books.
On graphs, okay? So, my point is, if you don't have a graph, if you have like a table, you're not looking left and right on a table. If you have just an equation without a graph, you're not looking left or right. That's why we need to understand it's the set of all x values or inputs. When we have a graph, we look left and right.
You said when we doing what? We're not looking left and right?
A table,
What? X. Okay. I don't know.
Miss Kenny, what about the
Hey, hold on, dude,
Not today.
I look at my X, right? Then I look at my Y.
okay? But if I'm looking at domain,
Yeah.
here's my domain, I'm not looking left and right, I'm looking up and down. If I'm talking about range, I'm still actually looking up and down. When we talk about the left and right direction, that's only the x-axis that you're referring to. My only point is that is specifically about a graph, but if I were to give you this equation, without a graph, without a table, without anything, I know that the domain here is negative infinity to infinity, because I know that I can substitute anything into that equation, right? Inputs is anything, so it's negative infinity to infinity. So, I just want us to make sure that we understand, it's not just looking left or right, that's only on a graph. It's all x values or inputs.
Well, I'm about to
Yes,
say the same thing, you about to say, I'm about to say the maximum, X and minimum.
so that's what I was gonna bring up really quickly, is remember, what notation do we use for domain and for range? I called it-
Maximum X and
We use that. Yeah, there's a name for that notation.
infinity and positive infinity.
Okay, you're not hearing me. There's a name for that notation.
Relative?
It's called
Interval notation.
interval notation.
Okay.
Okay, so when we say interval notation, what are we gonna write? There's two different numbers that you need to write.
X min and Y min.
So
X min and Y min.
so,
I mean, the X minimum, X max, and the Y minimum, Y max.
okay, so just in general, let's consolidate that. When we use interval notation in general, it's a minimum
Or the maximum.
and a maximum. And then what do we put in between to indicate that it can be anything? A comma, right? Today, we're gonna start getting into when do we use brackets versus parentheses, right? So sometimes you're gonna use a bracket, sometimes you're gonna use a parenthesis, but minimum and then maximum. And so when we looked at this function yesterday, what was the minimum x for that domain?
Negative, infinity.
Okay? Never quits going to the left. Right? Never quits going left, so the minimum x is
Infinity.
negative infinity. Does it ever quit going to the right?
No.
So what's the maximum x?
Positive.
Positive infinity. We had domain, we also had range. That was the set of all y values, also called what? Outputs, okay? And what notation do we use for that range as well?
Minimum Y.
Minimum and
Max.
maximum, right? So when I look at this graph right here, what is the minimum y value?
Negative infinity.
Does it ever quit going down?
Nope.
Nope.
You talking about
Does it ever quit going up?
no. Maximum Y.
And then what do I put in between to indicate that it's anything in between? Comma. Whatever that comma tells us is anything between that minimum and that maximum. That's domain and that's range. Okay, so it's a recap from yesterday.
Yeah, I just know.
That was from earlier. There you go. That was just from earlier. Okay. Now, you're gonna get some practice in a few minutes with this stuff, but before that, I want to talk about Extrema.
Extrema?
What does the word Extrema make you think of?
Extreme.
Extreme, right?
It's quiet.
Okay. So think like extreme.
This class.
Parkour.
Yeah, exactly. This class, maybe just, this class is supposed to be learning math, but I want you to think about words that are already up on this board, okay? I want you to think about words that are already up on this board that might indicate the extremes.
Maximum.
Is a maximum an extreme?
Yes.
What else? The minimum would be another type of extreme.
A lot.
Okay? So, this is on page 158. We're going to recap in a second. So, when we say extrema, what we are talking about are things called relative maxima, or maximum, and relative minimum.
Yes, sir.
Now, I need y'all to pay attention to this detail that I'm about to go into, because this detail right here will save you a lot of frustration, time, and energy. So, when we talk about a function like this, most students want to say that the maximum is infinity. Any guesses why they might say it's infinity?
Because infinity never stops.
Okay, well then what does this graph do? Does it ever stop going up?
No.
No. But can you ever reach an infinity?
Yeah. No.
No, you can't.
Can't do it, okay?
No, because
Infinity cannot be a maximum. Infinity cannot be a minimum. Don't ever put an infinity as a max or min. Go ahead and make that note to yourself. Infinity is never a maximum or minimum. Or if you're pressing, you're too cool to write things down.
Yeah, you know.
What do you say?
I told them in the lab.
Infinities can never be a maximum or a minimum. You can't get there.
You write down.
No.
Infinities can never what?
Be a max or a man, bro.
maximum or a minimum.
Okay.
He's not here today. He's absent.
Is it pretty?
Grady with a P.
Brady means to come back.
Oh, yeah.
So, looking here at this graph, this is what we actually mean by a maximum, okay? So I'm going to show you two things. May even mention a third, but here's what I want you to think about. You see this point up here?
Yeah.
In that area around it, is there anything higher in that area?
No.
So relative to everything around it, that's the what?
Maximum.
Maximum. Relative to the stuff around it, it's a maximum.
Match.
Okay? Down here, relative to the stuff around it, that's a what?
Minimum.
Notice it's a relative, meaning for its area, it's a maximum or a minimum. Okay? For its area, it's a maximum or a minimum. Here's a better way to understand it though. And this will help significantly. I think I started on this yesterday with y'all. Right here, if I were to draw a line and just make it touch one point, that's called a tangent line. Okay? But just touching one point. Is the slope of that line positive or negative? Positive. So what's the function doing through here? It is,
Moving.
in the mathematical term for going up, is
Cycle.
increasing. Okay? So it's increasing through there. Then, right here, what does it start to do? Decrease. How do we know it's decreasing through this area?
Because we see it going down.
Because the slope is, think about the slope. What kind of slope would this be? Negative, right? So the slope is positive here, slope is negative here, increasing versus decreasing. But where does that change?
When it hit that swoop.
When it hits that what? Not a zero. Maximum. That's the definition of a maximum. Think about a roller coaster. If you've never been on one, think about seeing one, right? When that roller coaster stops going up at the top and then it starts to go down, it's hitting a what?
A peak.
A peak, but what do we call that mathematically?
The stopping point.
A maximum.
Maximum.
So, a relative maximum and I'm gonna, yeah, let's just do it, is the point where the function stops what? It stops what? See that? So it stops increasing and it starts to
Decrease.
So it stops increasing and starts to decrease.
Decrease.
Good job, Christian.
Okay. So it is a turn. That is a detail. You can turn the desk if you want. Okay. So it is a turn. Relative maximum is the point where the function stops increasing and starts to decrease. It's a turn.
Mr. Kenny, may I have a right to?
You need a pass or do one?
Yes.
That's all right. They jump back and so I.
Okay.
Is it funny?
Give that joker back.
So what's happening at this point?
Okay, I can't.
Mr. Kenny, you can't see.
It stops what?
Moving.
Decreasing, and it starts to
Increase.
And so what are we going to call that point where it stops decreasing and starts to increase?
Minimum.
Well, it's a minimum.
Yeah.
That is
That's that point.
the point where the function stops decreasing So that's another type of turn, right? So when you see the graph turn, that's a relative maximum or minimum. If it's not turning, it's not a maximum or a minimum. Okay? So that's how we identify and define those minimum and maximum in a graph.
Yay.
Oh.
Bless you.
Okay. Yes.
What's that word after decrease?
Yes. It's the answer.
Like, after that.
Starts. Okay. Everybody needs a calculator in hand after you finish noting that so that I can show you how to use a calculator to find your max and your min.
We have Miss Brown. I mean, Mr. Brown in the middle. Can you get us off the calculator?
Yes.
Miss Warren. No, it was. It was so bad. Why did you do that? I don't. It's just like the way I thought it was. And then she said, "She calculated." Or like you got coffee problems.
So, you should have a calculator by now.
Where's
Excuse me.
Where do you want to put how to? I don't want to be a mathematician.
I still want you to learn
But I already
something.
learned how to count when I was in first grade.
The ability to learn is still something that's learned.
Oh,
So, excuse me, it doesn't take this level of talking to grab a calculator. What I need us to type in is the same function that we used yesterday.
What are we doing?
So type in this function, I think we made our minute, so if you're gonna change your window, I think we did -5 to 12. And then the minimum y, we made -100, the maximum y, we made 250. Okay, so I need you to graph that function.
My neighbor told me.
J Mike, I need you to create a graph. Not zoom out. That's because it's -10 to 15. You need to change your window settings. Okay, what's up? Do you know anything?
I remember.
So guys, once you get your graph in there, dude, come on, you don't even have the graph.
And then window setting. Okay, I got it.
Oh, wait, hold on. Then when I put the windows in.
There you go.
So,
So
couldn't change the middle of this is -5. Maximum.
you get 2 of the 3 words done.
Yep.
All right.
What you doing?
Bro, what are you doing?
Well, what the function look like? Did we graph this yesterday?
Yes, the one.
The very top.
So this is what we should see on the calculator. Does anyone need me or Mr. Hobby to come by and help me get that graph? Say again. And you didn't change the window.
To the window.
Remember how we changed the window settings yesterday?
Oh my God, it's like a dog bark.
So you abandoned Maddie? Oh, you said
And you sit to it?
No.
That sounds like
You
an
can ask Jamie. I've always
We
had
did
this car.
yesterday.
That sounds like an English bulldog.
Okay. So,
That is that function.
it's not that hard to still.
Okay.
So, right at this point, what I need us to do is learn how to use this calculator to find the fun little couple of details. What button lets me do cool crap on the calculator?
Menu.
Alright, so I'm gonna go to menu. Now, if I want to find my minimum or find my maximum, does anyone see an option that might help?
Window zoom.
Okay, you could do trace, it's not gonna be the best one.
Window
Window
zoom.
zoom.
Window zoom. Say it again, Jay.
See?
I want to analyze the graph, guys.
Oh, wait, what are you trying to do?
Analyze the
I did
graph.
something. I don't know what it is.
We've looked at analyze graph before to help us find what? What do we use analyze graph for? Zero. But what's right below it?
Minimum and maximum.
Maximum.
So,
Let's
let's do the maximum first. Now, do not actually do it. I need your eyes and ears on this because I'm about to show you something to help make sure you don't make a mistake. J Mike, I need your eyes up here real quick. When you do maximum, okay, notice what is the question in the bottom left-hand corner? Low bound, okay? And so if I hit enter here, it's now going to ask me for the upper bound, so I go to the right. You see how the graph is currently to the right of that maximum? Okay, so I can hit enter and I'm done. And there is my maximum. Here's my word of caution. Do not go too far. Because all that the calculator knows to do is to find the highest y value. See how it's found the highest y value? And if I keep going, it stays right there. But what happens if I go past it? It's going to change. Notice it identified this maximum because I was at the edge of my border. So only go around the maximum that you want. Do the same thing with your minimum. So I need everybody to use their calculator to find the minimum and the maximum for this function. So help each other get that going. You just good to go, Dwayne? You don't need it?
No,
I got it.
Okay, did you do your minimum and maximum?
No, I
So
don't.
do enough to go
No,
around. Right, make it clear to go around that. Okay.
I'm going to window.
No, not at all. No.
I did it in the beginning. I've been looking at me like that.
Bro. The work may not be done.
I did that. That's all I got.
I'm bringing the thing back.
What do you know? Did you show it or you make it? Okay, because it looked like you were just doing it for her.
Yeah.
Make sure.
I don't know why.
Right, my stuff
What button does?
If that was my
And earlier, when we were all working on this, and asked, does anybody need me or something to help you, you didn't want to raise your hand?
Oh shoot, we do a minimum.
Like, I can't tell you.
I just showed you the minimum.
They all have.
So this is max right here.
I need you to take advantage of the time we got right here. Okay, so,
That's the max.
Chelsea, you need help? Coming back together in 60 seconds. Okay, so, ladies and gentlemen, the 60 seconds is up, right here. And 60 seconds.
60 seconds.
So,
They're not like us, they're not like us.
sorry, Mr. Holly, hold on one second, so I can get them going.
Oh my God.
So, what is my relative maximum for this function?
The relative maximum is 2.27,
2.2.
comma 22.8.
So, now here's the thing. You can have different decimals, that's fine, like as long as it's just like a rounding error difference.
Yeah, it's 2.
One thing I will say is this. I'm not going to sweat this with y'all, but one thing I want you to be aware of is when we say maximum and minimum, what we really mean is just the output, right? You can write the point, but what we technically in mathematics mean is it's a relative maximum of 228 at x equals 2.35. So that's something to keep in mind too, right? But you would just report the relative maximum is that point. The relative minimum is right here. At this point, that's pretty much it. You need to be able to explain these things and explain what they mean, but this is where I have given you this sheet that has mild, medium, and spicy. What I want everyone to do right now is to work with their small group on identifying the zeros and their multiplicity, the degree, the domain, range, and extrema for each function given. If you need extra space for the back, you can do that, but I want you to get to your vertical surfaces and work on each of those functions starting in the mile. Hey Jamie, quick question. How's that music? Yeah, I don't need more to the sides, I actually need way less, maybe -5 to 5. I don't need to go lower in the y, I just need to go higher in the y, maybe 25? Now, can I see the graph okay? Probably might go a little bit lower with that y maximum. But, look around the room. When I look at this, I need to, what was the first thing I asked you to find? The what?
You said don't do negative.
I asked the zeros first. Remember, your calculator can literally find the zeros. And I heard someone saying, hey, it's not showing me the zeros. Am I talking? It's weird, because now it's silent. All right, So we have these zeros allegedly, but guys, are these actually zeros, these points right here? What are those points? Those are x intercepts. Remember, my 0 needs to be this.
I can't see it.
This guy, I'm trying to put the X forward.
Okay, I'm talking, chill. X equals -1, X equals 0, X equals 3. But how many times do we have this 0 right here? Why is it only one time? What's it doing? Just going through. What about X equals 0? You see how it's touching and then bouncing? That's a multiplicity of 2. And this is a multiplicity of 1. Pick back up with that tomorrow.